Okay. Today I'm going to talk about two things. CASI, it's a center we have at CERL, and a LEED Platinum project that we've done for the Army. And I have about 80, but I'll go fast. This works. Okay, I don't know if you know much about CERL. We're an Army Corps of Engineers research lab. It's Engineer Research and Development Center. We're located in 4 different locations. CERL's a part in Champaign. There's 4 labs in Vicksburg, Mississippi. There's 1 in Alexandria, Virginia. And then there's 1 in Hanover, New Hampshire. And CERL's mission is to enable sustainable installations through transformation technology. So we're an allied agency with U of I. That's why the lab is in Champaign. We have a lot of different research facilities at CERL. I won't go into all these, but there's a lot going on. CASI was started in October 2006 to support the Army strategy for the environment. There was so much going on at CERL, and there was a real need for embedding this into the Army. So it's the Center for Advancement of Sustainability Innovations. I'm Center Knowledge Engineering, which I've got the website, and I talk to a lot of people, I guess. Bill Garan's our director. I don't know if you know him. Michelle Hansen's the associate director. We have an Army definition of sustainability, and they really are taking this seriously. This was a definition that was created in 2004. So in 2007, the Army Strategy for the Environment won a White House Closing the Circle Award. And the goal is to foster a sustainability ethic and really embed this Army-wide and to create policies that do that. And you've heard of the triple bottom line. Our triple bottom line is mission, community, and environment. We have an Army energy strategy. There's a lot of work in saving energy. We have so many facilities. And also, we use a lot of fuel when we move around, too. Microgrids is one of the really big work efforts. I'll talk about that a little bit. There's a new strategic plan for Army sustainability. And we're trying to get that into the Army. There's a leadership school. We get a lot of the different leaders through to teach them about sustainability. There's been an ongoing effort for quite a few years now where we have 25 years visioning processes at these Army installations. Fort Bragg was the first one. They set 25-year sustainability goals. One of Fort Lewis's goals is to be 100% renewable energy in 25 years. They have really big goals. Bragg cut 30% of their water usage in 1 year after they did that. And there's a big process that's been worked on by a lot of people. And that's a really good movement. It's a movement, really. We're looking at getting the Fort operations to be more sustainable because we have to reduce water and energy requirements. It's a risk for people to drive around bringing you water or fuel. And that includes civil works operations and facilities, too. These are the main focus areas that CASI deals with. I know this is one of those slides that you can't read very well. We'll go through each of these business areas real quickly. Sustainability measures and benchmarks. We're trying to do a Army sustainability annual report following the GRI format. Trying to figure out how to have policies and measure indicators to drive the Army to be more sustainable. Michelle Hansen's the lead on this. The SSA project, Strategic Sustainability Assessment. One of our leaders is here with us, Elizabeth Janacek, looking at 30-year futures on a regional scale for different sustainability indicators. Is there going to be enough water? If we change water policies. How much water can we save? Doing forecasting and backcasting analysis with regional stakeholders to get them to buy in. Look at land use change over time policies and how that affects growth and use of water and energy, things like that. This is a really interesting process. There's a lot going on with energy, but one of the focuses is microgrids, and that's the ability to connect the loads and the renewable energy sources efficiently so that you can share the loads and get the energy where you need it. And this is apparently really hard to do. I guess there's not a lot of technologies that work right now.
I have a question about that. If we're already connected to the grid, right? If I put a solar panel in my house, can't I just feed that in?
No, we're thinking you're out in Iraq somewhere.
Where?
You're out in Iraq somewhere and there's no grid for you to plug into.
Oh, okay.
So you're going to have to set up your own microgrid with renewable PV, waste to heat, or whatever.
Okay, but not in the U.S.
One of the things, there's an effort to get the installations to be off the grid for 6 months. So they're thinking, how do we go self-sufficient? How do we do this? It's a challenge. We don't know how to do it yet.
Some of it is in the U.S., and that's in the area of energy security.
As far as reliability, or
Yeah, having our own standalone systems that'll work when the grid fails.
The grid. Well, there's a lot of risk at continuing the way it is. Sustainable contingency operations being when you have to send people over, you're building a small city to either provide aid, reconstruct a country, whatever. We developed a research framework for how to be more sustainable in the future, tying all the ongoing efforts together and figuring out what's missing. And we're plugged into this big network of people that are doing this effort. There's a real need to do this differently. About everybody in the Army's been deployed once or twice, and they see a lot of problems with the way we're doing business. And there's a big effort to change and be more sustainable. You know, energy and water are big problems, and sewage. Sustainable water resources. Elizabeth is the lead on this. One of the projects we have is to look at 30-year water sustainability at Fort Bragg and Fort Bliss, to look at how will demand increase, how does the population increase, how do we apply technologies to save water, what's the region doing. The Army's adopted, for instance, waterless urinals for all new projects. How does that affect? How many buildings can you get those into? There's a lot of water modeling going on with this effort. This is the one I have a hard time explaining. So I have a sentence for you. We're shifting to a trading framework of credits, carbon, habitat, water quality, and wetlands. And that's already affecting the military conservation easements. So Cassie's helping the military prepare for this change. So this is a new research area that's got a lot of growth potential. There's an effort to deal with climate change. There's an interagency working group. Bill Goran and somebody from NASA are co-chairs on that. They meet every other month in Washington, D.C. They're looking at how will climate change affect the federal government, federal facilities. What do we do to deal with climate change? How do we have policies to help out with that? There's going to be a workshop in Alaska in July. I should say there's a workshop in Urbana for the water project too. November 12th through 14th. Military applications for emerging water use technologies. The water campus is part of that. This is the business area I work in the most. We've been doing this since 1999. These are some of the reports we did. We did a Lead for Homes pilot for the Army. Julie Webster wrote a DoD guide for historic properties, basically how to use LEED-EB for historic properties. We wrote the Army's LEED implementation guide. Right now, all Army buildings are required to be LEED Silver certifiable, which means they're not necessarily paying the USGBC to certify the projects, but they have to design them to meet LEED Silver and do all the documentations to prove that. We started a directory of expertise for SDD. Rich Schneider and I and Judy Milton from Savannah District are the leads on this. So basically, we're providing technical expertise to the Corps of Engineers on a reimbursable basis. And we help with the analysis to keep our policies up to date as LEED products change. We're going to be going to LEED for 2009. So we have to figure out how do we do this? How does this work with the Army? And we do a lot of training and talks. So you probably don't need this. We're on some of the committees, and we're corresponding members on most of the things to see what's going on. One of the real issues is the LEED portfolio and certification strategies. We build so many buildings. We're trying to figure out how to certify a barracks once, figure out what the normal credits are that you could get for your other barracks projects on a portfolio basis. This is interesting. The U.S. military and the Chinese military have a partnership, and they've decided they can talk about green buildings safely. So Rich Schneider went to China last year, and somebody's going to go this year again. The Chinese are building a military campus similar to West Point, and we're working with them to help them do that as sustainably as possible. This is Mr. Van Houten and his Chinese counterpart. It's apparently quite a big deal. I didn't get to go to this yet. So. We've been funded to do a validation on how well we're actually doing on our construction projects. You know, you can make a rule and tell people they have to achieve LEED Silver, but are they doing it? Are they getting there? So we're going to pick some sample projects and go validate them for the Army, and we're also going to pay the USGBC to certify some projects. And part of this is to talk to people and find out what the problems are so we can help improve that. This is the real fun part of the talk. I'm going to talk about a fire station we're building at Fort Bragg. This is kind of complicated because we combine 3 different projects. Okay, the first project is a normal military construction project to build a community emergency service station. It's in a new residential neighborhood on the north side of Fort Bragg. And we negotiated to get it design bid build process instead of design build. On top of that, we have a 4-year research project. It's an environmental security technology certification program, and it's to try out whole building design. And then on top of that, I had another project, early design energy analysis using BIM, building information modeling. Has anybody here used BIM? No. Okay. Few. So the AE that worked with us was HSMM. So the BIM objective, the Corps of Engineers is using BIM for all our new designs. And I found an energy analysis tool, Green Building Studio, that lets you submit a BIM model in GBXML, and then you can do energy analysis. So I wanted to see if we could use that early in a design charrette to really design the building and make sure it's energy efficient from the start. It works with Revit, AutoCAD, Revit, Triforma, and ArchiCAD. Now Triforma is of course standard, and it doesn't quite work very well with that yet, so we're still on hold on that part. So we're going to try to test out Green Building Studio with the design shred and also with a retrofit project. Does it work? Can we explain this simply enough that project teams can use it? So typically when you do an energy model of a building you're designing, it takes a while to do the modeling. This takes advantage of having the architect design the building in 3D and use that 3D model right away to do an energy analysis. The ESTCP project is a demonstration project funded by DOD to see whether whole building design would help us get a better project. So we were going to assist the architect of record with design, modeling, and lead, make sure that the building can meet high performance objectives. And we're going to monitor the performance of this new project against an existing project for a year and see how do the results work. The bottom, I guess I have a pointer. This is the existing fire station at Fort Bragg. And these are two of the design drawings from the 35% charrette we did. So we're going to compare the new building with the existing fire station. Now we started modeling the existing one and we realized it's stupid because when your high bay is in the middle of the building, it just pollutes the whole building every time the trucks drive in and out. You really don't want that. This project team was pretty big. We had people from Corps of Engineers, 2 different districts, from CERL, CH2M Hill, IMCOM, Installation Management Command, Fort Bragg, South Face is in Atlanta, they do sustainable design, Pacific National Northwest Lab, and the AE, who was very kind to work with all of us. These were the performance goals for the building. We're trying to get LEED Platinum, 50% energy reduction over base case, 30% water, 50% wastewater, and a 25% decrease in operational costs. And we wanted to do this within PA, which is what we call program amount. That's the normal construction budget. So this was the schedule. The first year we're going to work with them in design. Then we're going to share the lessons learned with the services, work with the builder, and then monitor and validate it. The whole building design is a team effort where everybody has to talk to each other and you get better sharing of ideas, you get a better design than the typical process where somebody draws the plans and then they give them to the engineer to do the mechanical, the electrical. We had a 4-day charrette at Fort Bragg. This is our customer, the firemen. Before we went, we did 4 energy, we modeled the existing fire station, energy use. 2 different teams are doing energy modeling, South Face and also CERL. South Face is using eQuest and CERL is using this BIM energy tool. So we had 4 buildings. We had this one, 2-story with a separate high bay, 1-story with attached high bay, or 2-story attached high bay, and 1-story attached high bay. Now, for Fort Bragg, North Carolina, which building would you think would be most energy efficient? You have to answer me. This one?
Yeah, sure.
That's what I thought, but that's wrong. This was the most energy efficient. It must be because of the cooling. I don't know. Anyway, we started the charrette with this. We found that we could not convince the firemen to have a 2-story building. No way, no how. They weren't going to go down the pole. They have a minute response to run out and be in the truck. So the charrette, the basic plan is a high bay that they can drive through. I should say the building has a fire truck, a police car, and an ambulance. The sleeping rooms are up here on the north side. This is the entry, the public space, reception. This is the firemen's day room where they can eat and cook. Interestingly, there's a lot of fires in these kitchens. A lot of them have huge smoke or fire suppressors because they're cooking up something and they get a call and they run out. And yeah. So these are some of the offices. There's a holding cell here for people that get out of control and they have to go capture them and put them in the holding cell until they chill out. These are the restrooms. They always have a fitness facility, a training room. This is the mechanical room. So that's about the basics. The architect did a bunch of different roof scenarios, alternatives. Here's one of them. Oops, let me go back. So south is this way, okay? Here's another one. When we did the energy modeling, it became apparent they weren't getting the LEED daylighting credit because the interior spaces were all dark. So they started putting in skylights. This one was kind of fun. This was the celebrate the rainwater collection roof. You know, like this. And we're going to collect all the rainwater and wash the fire trucks with the rainwater because that's a process load with a lot of water use. Well, the guys at Fort Bragg just went nuts. They did not want to collect. That looks like a roof that will leak. Okay, so that got voted down. This was another alternative with the clear story. And then this one faced south. The high bay skylight faced due south. So we kind of all talked and voted on these. One of the benefits of using BIM is you can just take floor plans, elevations, sections through the building, and just create these drawings because you've got a 3D model already. So these are some of the drawings. It's quite an eye-catchy building. One of the benefits of building on the north side of Fort Bragg is it's not by anything else it has to look like. It can be creative. So you can see the high bay in the spaces. So these are some of the technologies we used in the project. Insulated concrete forms. This saves a lot of energy. You can have a really efficient wall. You just you set up the forms and pour the concrete in. Oops. We were trying to do geothermal heating. I don't know if this ended up in the final project. They're still debating the energy system. They've got alternatives, and whoever builds it gets to pick it based on cost. This site is an all-electric site, unless we use propane. There's no natural gas there. We're going to do solar water heating. It's cost-effective in this application because it's a residential use, too. We've got those people sleeping there. And it saves a lot of, estimates showed 5% energy savings for the entire facility. This is one of the things afterwards I kind of decided I don't like. We're using solar walls. These are solar walls. So they heat up the air behind it, and then you can blow it into the space. So on the elevation, you see that black line around the south. That's the solar wall to heat the high bay, which sounds good until you think, well, they're going to open the door and all that hot air will blow out. So the guys at CERL told me we should have used a radiant floor instead because that would keep the people warm. We use these a lot, though, on mechanics shops, maintenance shops in the Northeast.
Was that heating the whole center? Could you still do radiant floor, or is...
I couldn't get that into the project effectively. One of the lessons learned was I gave them a really thick document and they didn't read it, but the people that researched the little technologies that gave them short, tasty, little cost-effective ideas, those got implemented much easier. We're going to collect the rainwater. We tried to have 2 cisterns, one for the washing the fire trucks, one for flushing the toilets, but it ultimately ended up 1 cistern just for the fire trucks.
Because you don't have enough for
Partially that and partially cost of the redundant systems. There was value engineering that occurred at the end of design. We're going to use DDC controls. There's a network on base to control the buildings. And this helps us monitor the building and compare it to the existing building. That's direct digital controls if you're not. This is a site plan. And at one point, the civil engineer came running in all excited. And he wanted to scoot the building. It's kind of up on a hill, okay? So the fire trucks would drive in and then drive through the high bay and out onto the road. And the residential area is over here. And this is kind of a public road over here. And this is the visitor parking with the visitor entry. So once we moved the building a little bit, he had a lot less cut and fill to do, so it was more cost effective. And that's part of the whole building design is having everyone in the room. The architecture firm had a cost engineer, mechanical engineer, lighting, civil, the BIM guy, the lead. There was a couple other people. There was 10 lead accredited professionals in the room because we all descended upon this. But they were very nice to us. Everybody was in the back researching. They'd come up with some problem and somebody would be researching it. It worked really well. Fort Bragg is very progressive in sustainability. And they were trying to get natural landscaping for the fire station. Now the fire chief has the green turf lawn in mind. So we collected some pictures to try to convince him otherwise. This is a fire station in Texas. It has nice native planting. This is some of the landscape around Bragg. There's a lot of pretty ferns. This is what the site looks like. So we tried, I think we got down to one little green grassy lawn that can kind of put their golf outside their kitchen window and the rest could be native. This is the cost estimate at the end of the charrette. Came in pretty close. Now there's something in here that is really a money hog, this supporting facility. This is an 11-mile cable run to hook up that part of the post to the other part of the post network. These are some of the other credits we're getting. This is sustainable site credits, bike racks, cool metal roof, bioretention on site. Water efficiency, there's no urinals in this project, so we're going to use dual flush toilets. Have you seen those? They have a big flush and a little flush. Low flow fixtures, all drought tolerant species. Geothermal heat pump, although I'm not sure if this will end up with this. We'll have the solar wall, solar hot water. It's really a good passive design. We tweaked it during the charrette. I'll show you the energy models. Occupancy sensors for lighting. And you have to be real smart with these because there's daylighting sensors, there's occupancy sensors. And this is a 24-hour occupied building. So you have to pick the right sensors for the right rooms. Commissioning is really important to get this to all work right. And then the ICF envelope really made a big difference. Insulated concrete forms. Materials, we had to be really strategic. We're trying to get to LEED Platinum. Like FSC certified wood doors, we can get that credit. If we don't have too much wood in the building, you can afford it. If we have wood trusses, there's no way we can afford this credit. Rapidly renewable materials, we can put cabinets in the kitchen and linoleum floors, and that's enough of a budget. So you have to take your building budget and compute the costs of these different parts to get the credits. Construction waste management is a really big deal. There's an Army policy. We have to recycle at least 50% of it. Fort Bragg has a stockpile. When they tear down old buildings, they take all the concrete, they grind it up, they reuse it. They stockpile topsoil, they stockpile all kinds of stuff. They're really good about this. Indoor environmental quality, you have to cover up the ducts. You don't want people throwing their pop can in the ducts, during construction, and then it stays in there. We're daylighting the spaces. A lot of emphasis on controllability of systems. Operable windows. You won't believe how much of an argument we had to put operable windows in. A lot of Army people think there's force protection rules to not have operable windows. And the argument just goes around and around. But
so wait, for breaking and entering, is that the argument?
Yeah, it's like, well, what if you don't have any energy and you have to open the window to get air? Every base I've been to, we've argued about this. Increased ventilation, we're having an energy recovery ventilator. Moisture is a big problem in buildings, so you want to have the supply air conditioned, or you are providing fresh air and conditioned air in 2 systems. And you have to have permanent walk-off mats. That's another credit. Innovation and design, this is another way to get to platinum, is to get all these credits. Process water reduction, that's the water the fire trucks with wash the fire trucks with the cistern water. All light colored hardscape. 40% water reduction. The building's an educational tool. We set it up so we can take tours through. and they can see the mechanical room. There's windows into it. They can see where the air comes from the the preheater to the high bay. They can see the solar hot water system. You can see the cistern. There's a lot of kids that go on school tours. We're going to have some cutouts in the building. There's several lead APs on the team, so we got that. So at the end of the charrette, we had 57 points. That's a lot. Now, this is 35% design. So energy modeling before the charrette, we did the underground and the 3 other alternatives I showed you. Now, there was a big push by a couple people at Bragg to build an underground building using 18 Connex trailers, you know, the old shipping trailers. Okay, they want to be leaders in sustainability. Can you imagine the space you get from 18 trailers under the ground? We're like, they're going to rust. Oh, you could put that rhino skin on them that you put in the back of a pickup truck. We're like, why don't you try this on another project? So we managed to get a nice design. During the charrette, we took the 3D BIM models. It took about 2 hours per design to fix the model enough to do the energy run. Because the architect was designing them to look right, but all the spaces, the volumes weren't closed. He had furniture in there. He had parts we don't need to do the energy model. So Hanju Kim sat and fixed the models, and then we could just export the GBXML and do the energy run. So we did the 3 preliminary designs, and then we did the final design. And this is what it looks like in Green Building Studio. You can see the building. You can spin it around. You can click on walls. You can see where they are. GBXML is Green Building XML, and that's the file format that you're going to get out of your BIM tool to put into the energy modeling tool. And you can see all the runs. You can see the fuel cost. It also has a carbon footprint. It's really interesting. It's in terms of Hummers. It's 15,000 miles driven in a Hummer, so you're comparing your buildings. This is a 5 Hummer building versus a 3 Hummer building. It also models all the PV surfaces possible because it's 3D and water. So we did our energy modeling against the base case, ASHRAE, and we picked a whole bunch of options, and these were the best ones. So then for each of the 3 buildings, this is a chart that shows the 3 original alternatives, and this is the final building. This is the energy used by the base case for that configuration and the one used by those features you just saw in the previous slide. And we got down to saving 40% of the energy over ASHRAE base. Now this is really preliminary. You know, later on they'll do more energy analysis to design the mechanical system. But this was a good way to talk during the charrette about energy decisions. This is the building. And this is the cistern. You're walking under it when you go into the building.
Did you say cistern?
Yeah.
The water is stored up there.
Yeah.
And if there's glass on the side?
No, they took the glass out. We argued about that. Actually, this has been redesigned. You have to realize we were in a hotel all week next to this brewery pub that had the big cistern showing. You've been there, right? So we thought, well, let's just celebrate the cistern. People have to walk under it. It's part of the building as a learning tool.
But it's raised for static pressure, is that the reason?
Yeah. Yeah. And these are the guys, we saw them earlier, they're pasted in. This is our solar wall, and this is the hot water. They're coming and going under the cistern there.
And then what was that decision about shifting that building at an angle? That was made at the charrette.
Yeah, during the charrette, we were doing the energy alternatives, and the architect came running in and he said, can we shift the building 10 degrees because it'll be better for the fire truck? And so we did the run. It was like $86 different over a year. And he ran off, and they turned the building to optimize so the parking or the garage is at a different angle than the rest of the building.
It was for the egress onto the street, right?
There they are again. So this was a charrette success. This is the team. We've now got 55 points. 38% modeled energy savings. That's the South Face Energy Modeler. It's $100K over budget right now. So whoever builds it is going to have to do, I mean, there's some decisions they'll make.
So 3.5%
Yeah.
over budget.
Yeah, it's not bad. These are some of my websites. I've got the Army Sustainable Design website. This is a community of excellence for the Army Corps of Engineers. We've got contacts at all the different districts that are lead accredited professionals or contacts. But you guys can't get into this if you don't have a CAC card. This is a CASI website I run. If you have never seen the whole building design website, it's really worth a trip. And it's got all the federal criteria on it. I think that's my last slide. Oh. Somebody sketched this in one of our charrettes. It's a doghouse. You want to see it better?
Yeah,
I'm not a sketchy architect. I'm more of an engineer architect.
I like the urinal.
Yeah.
I use them.
So do you have any questions?
Did you find that working with the AE, because you were asking them to provide a little more in-depth design and more stress than they might normally provide, were they asking for higher fees?
Somehow that was negotiated with the AE, and they were very receptive. Although we had ground rules of communication, like we can't just talk to them anytime. If they asked us a question, we could answer it. We had meetings with the lead AE, the architect, to decide how do we interact with their team, because they're under contract with someone, and that's their rule. But they were really inspired to try to get on a LEED Platinum project, high visibility. So I suspect they may have invested a little marketing money, if you will, to this. They brought the BIM guy. When I was in the preliminary meeting, I'm like, oh, I could do this BIM energy project if you bring a BIM guy. So we tried that out too. They were very receptive. And they got a lot of information before the charrette so they could kind of get used to it and think about it so they could come in prepared, which is another lesson learned. Because I don't think normal charrettes you'd come up with all these ideas to get a LEED Platinum. Do you have any other questions?
Yeah, I have a question. Describe a little bit more of the relationship between the architects and the engineers. My experience has been with this building where the architect was actually the lead. And my understanding is normally the engineers are the lead. But it just seemed like in your case, I don't know who was really sort of the final decision maker and in the lead. But what I really wanted to ask you about is, doesn't it seem like it'd be easier to try to find the most energy efficient sort of mechanical systems and then design around that? But this seemed more iterative. So I just wondered, how would you recommend somebody do this in the future?
Okay, I studied architecture here at U of I, and I took mechanical engineering. I took thermal heat transfer and fluids. I'm probably the only architect you'll meet that did that. And we have all these energy rules. It's my theory that you can design the building configuration, windows, orientation, envelope, and meet your energy targets, and then have a really efficient, smaller mechanical system. But you have to do the building part first. So in terms of the lead, the architects are always the ones sketching out the plans to make the customer happy, But they never had feedback before on how to improve the energy efficiency. It's interesting, the last design came in and it was even better than the other ones. So they took the feedback from those. I don't know, this was probably a very different project. They were probably on their best behavior because there was all of us in there, and we were trying to get LEED Platinum. So part of our research project is to distill those lessons learned and share them. How do you do this? How do you repeat this?
So you would recommend repeating it for every building?
We have planning charrettes for all our buildings, and we have design charrettes for all our buildings. what we need to do, I think, as a research team is to come up with small, digestible, short technology sheets that people can use to understand how to include these new cost-effective technologies. Standard designs. Yeah, one of the things we're doing is we're working with the Centers of Standardization. We've got 28 standard designs. So we're working with them to learn the lessons too, so they can have a better standard design that you could then site adapt. And since we'll have those in BIM, we should be able to do energy models, plunk them somewhere, try that climate zone, see how that works better.
How is maintenance calculated?
They have very detailed performance goals for the ESTCP, and they had some cost. I don't know how they did that. Annette is the lead of the ESTCP project. She's from Installation Management Command, and she has access to cost data like that. And we have a goal that it's going to be more cost effective than the normal. We don't know. That's part of the research. Can we do this? You have to make a durable building then, right? And it has to be low enough tech that it's easy to fix with a high school education. I mean, we don't have rocket science taking care of our buildings.
I'm trying to give a bigger picture here. This hasn't been built yet. There's an existing facility now.
Yeah.
So what will happen if and when this is built? What will happen to the existing facility?
They're serving different populations, so they'll both be running.
So they'll both be running.
Yeah. And then the firemen are living in an experiment because they're measuring their trash, they're measuring their water use, their energy use.
Okay.
They're living in an experiment. That's part of the deal.
Okay, but the point is here that the Army is trying to reduce energy by building more facilities.
No. That's not the point.
But you are using more energy by continuing to
We're building the new fire station because we're building a whole new neighborhood of housing, and there's no fire station that services them.
If you didn't build the one we just talked about, you'd build something else.
Yeah, we'd build it.
You have to build something.
Yeah.
But is it realistic that the Army will ever use less energy? That's what I'm getting to. Keep building more stuff.
I didn't put those energy charts in, but there's federal laws that make our slope go like this, our energy use. It gets harder and harder to meet because we got a lot of buildings. So the new ones coming online have to be more energy efficient. That's part of the rule. The Energy Policy Act of 2005 says they all have to be 30% better than ASHRAE standard. We've got guidebooks on how to do that. We've got training.
But the energy consumption continues to increase.
No, it's going down.
No, it's coming down?
It's going down.
That's been coming down since the first energy crisis in the 70s.
Yeah.
Okay, that's interesting.
It's,
So the measure capital
Per square foot.
yeah, per square foot.
Per square foot, but there's more square foot. I'm interested in total energy.
We are too.
And that's coming down?
Yeah.
Well,
I had that chart. I didn't put it in here. Yeah, our population moves around and it affects our energy use.
Well, I guess if we could follow on his question, does the Army have in place programs for backfitting existing buildings to make them more energy efficient?
Yeah.
Yes, they do.
Lead EV. Yeah, we're looking at portfolio. Bragg's doing 43 buildings, lead EV. They picked the most interesting strategic buildings to really get them operating. Lead for existing buildings. Oh, we're doing lead for neighborhood development too. We're doing campuses like Fort Carson's building 5 new communities. They've got the guys that build the big box stores to talk to the guys that provide housing and put mixed use facilities in against their will. They like doing their big box stores. No, you can't build here unless you mix it up. So they've got these 5 really neat mixed use neighborhoods they're putting in infill. So there's a big picture effort to make sustainable communities.
What's the building density? Density of buildings?
Oh, here? It's not very dense. I mean, there's a few public buildings per se, and then there's a housing community, which is relatively dense.
But is it dense like, you go into a Europe district?
No.
Are there any movement towards that kind of?
The Fort Carson example in Fort Lewis has more density. They've got neighborhoods that are mixed use with multiple story buildings. They've got forms they have to fill, multiple story, little setback. So there are some high density neighborhoods. This is more like your suburban neighborhood. Well, they're pretty dense. We did the Lead for Homes project. There's a lot of multifamily housing. Any other questions?
I have one. Just could you
Okay.
talk about technology transfer? I mean, how much of this information is available to universities or architects and engineering firms in general, so that we can learn from what the military is doing?
My website, I put everything there. We have virtual teams that are private, but this is public. I've had a public website for a lot of years, and I've got all kinds of stuff on here. I think the new hot topics are the low impact development, construction, demolition, waste management. When people call, I end up usually telling them to go there, and I can show them where to find stuff. I'm doing a talk at the USA Small Business Conference, which is all the small companies that build our buildings. So that's a tech transfer opportunity.
There's also participation. I'm in the energy branch. We participate in the AED forums, which are public.
Yeah, we're like a university. We get bonus points for publishing and talking and journal writing and, the normal things. But we're willing to share.